you were to take a table of special angle values, so if you look at the top of the page right here that I'm pointing to, these are all angles that you certainly know. Minus 2, well, you should have been able to do minus 2 pi, minus 3 pi over 2, minus pi, etc., etc. If those are your x coordinates on a graph, right, and the y coordinates represent the value of the special angle. So just for instance, let me grab my stylus here. I can tell you that the sine of 0 is 0, just as an example. The sine of pi over 2, hopefully this is something that you know, right? And this is not, when I say something that you know, you should have known this from what I did with you. So I know that you're supposed to know this. The sine of pi over 2 is 1. The sine of pi is 0. This is minus 1. Then we go back to 0. So that part should not come as a surprise to you, right? If I went back the other way, this would be 1, this would be 0, this would be minus 1, and then this would be back to 0 again. If I now use those values to create a Cartesian graph, it would look like this red line that I'm pointing to right here. I'm tracing out this red line here. Notice it starts at 0, 0, 0. So that would be right here, this coordinate that I'm pointing to, 0, 0. At pi over 2, it goes up to 1. At pi, it drops back down to 0. At 3 pi over 2, it's at minus 1. And at 2 pi, it's back up to 0. So this table is at least something that you should be able to draw, even though you may not have seen the graph before. But the fact is that it does follow this up and down, what's called sinusoidal pattern, right? So it goes up, it comes down, it goes down, it goes up, and it continues in that fashion indefinitely. So that's what your sine function looks like. So the red line represents your sine function. The blue line, on the other hand, is your cosine function. So you're supposed to know that the cosine of 0 is 1. I'll remind you that the cosine is your x-coordinate. When we're doing that circle earlier on, and we're going from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi, we said that the cosine of 0 was 1 because the x-coordinate was 1. At pi over 2, you went to 0. Then when you went to pi, remember, no, excuse me, that pi would be on the other side of the x-axis. So you're at minus 1. And then you're going to go back to 0. And then you go back up to 1. So if you look at the blue line now, it's actually following that pattern. So you start at 1 at 0. You go down to 0 at pi over 2. That's what this says. You go down to minus 1 at pi. That's what this says. At 3 pi over 2, you're back to 0. When you get to 2 pi, you're back up to 1 again. It just simply follows that pattern in a repetitive manner. It just goes up and down, up and down. Now, if you sort of look at the table that I have here and think about this as being symmetrical, then it means that if I went to the left of this, I'd have 0 here. In fact, if we were, and yes, and let's just draw a quick circle here. You're quite right, and I'll change that in a minute. And this should be positive 1 here. I'll change that as well. I understand where the confusion is now. If I were to draw, I'm just going to add a page. And hopefully you remember this circle. So this is, I put a little rough circle on here. Not a great circle, but it's a circle. And if you started off at 0, then this would be 1, 0 here. This would be 0, 1. This would be minus 1, 0. And this would be 0, minus 1. So if you're going in a negative direction, and by the way, this would be 0 degrees. This would be pi over 2. This would be pi. This would be 3 pi over 2, going in a positive direction. But if I'm going in a negative direction, and you're right, I'm going in a negative direction, then this down here would be minus pi over 2. This would be minus pi. So minus pi and plus pi in the same position. And this would be minus 3 pi over 2. Okay, so if I'm going in this direction, I'm looking at my y coordinates, then at minus pi over 2, then yes, it would in fact be minus 1. So I stand corrected on that, Jeremy. Okay, minus 1 there, then 0, then 1, then back to 0 again. Okay. On the other side of that, for the cosine, does that make sense now, Jeremy? Are we good now? Okay, you're welcome. On the other side of that, for the cosine function, right? We're starting off at zero, starting off at one, sorry. We're going to zero next. Then we're going to go to minus one at minus pi. Oh, let me just think about that for a second. Yeah, minus one. Ah, wrong color, wrong color. And then we're going to go back to zero. Then we're going to go back to one. So it's just that there is this sort of symmetry about it, right? If you think about it. And this is what the graph looks like. So it's going up, going down, going up, going down. But then the cosine graph starts off at its high, then it gets to the middle, then it gets back to, then it gets to its low, goes back to the middle, then it goes back to its high. Now, does anybody, so those graphs and those tables match up, right? Does anybody know what the term amplitude means? And we're talking in a mathematical context. The word amplitude can be used to talk about the intensity of sound. That's one way to use amplitude. But does anybody know another use of the word amplitude in relation to math? Okay, so I see a hand up. Jeremiah, what do you want to tell us? Mm-hmm, mm-hmm. Okay, there are two ways of looking at amplitude, and I'll tell you both. One is to do what Jeremy just said, which is to go from the highest point of the function. So here's my sine function I'm pointing to now, the red line, and go down to the center of how this thing is moving up and down. So it's always good to have that center line in. I'm going to put that center line in for you now. And that center line in this particular case, not in all cases, the center line in this particular case is the x-axis. So I'm going to put that in as a dotted line. I'm going to put that in red. Okay. So this center line of this function is the x-axis. So any distance from the highest point vertically down to that center line, that distance referred to as the amplitude. Another way to determine the amplitude is take your high minus your low and divide that by 2. So in other words, the distance from the high to the low, the highest point here is 1. Oh, let me go back to the stylus here. The highest point here is 1. The lowest point is minus 1. So if I take 1 minus minus 1, that's of course equal to 2. Then I just divide that 2 by 2, and that gives us the same value of 1. So both ways work, right? Either you measure the distance from the center line up to the highest point, or just take the high minus the low, and if you're minusing a negative, then remember you're adding, and then divide that by 2. In other words, what is that distance from the high to the low? That's really what you're saying. How far apart are the high from the low, right? Because whatever that distance is the amplitude divided by 2, it would be the amplitude, I should say. So you have to divide that distance of the total from the high to the low by 2 to get the amplitude. It's like half the distance from the high to the low. So we're going to be, therefore, saying that the amplitude of the sine function is 1. What about the amplitude of the cosine function? Not Jeremy this time. Let's see if anybody else can work out what the amplitude of the cosine function is. Anybody? All right, so use the same approach and tell me what the amplitude, it would also be 1. That's correct. Okay, so both of these functions have an amplitude of 1. Let's get to the period of the function now. Does anybody know in a mathematical context what that means? So let's restrict that definition to trigonometry. Okay, let's see. Jeremy, go ahead. Mhm. Okay, so let me repeat what he just said. 1 second. Let me just get rid of this little thing here. Right. So really what we're asking, so when you're asking about amplitude, Noah says, is it 2 pi? It is 2 pi. When you're asking about amplitude, you're asking how far is it vertically, right? From the high to the low. When you're asking about period, you're asking about how far is it horizontally to complete one cycle. So the way I like to do this, I know what Jeremy said, but if you're able to see two high points, then I find it convenient to measure the distance between those two high points. So one high point, for instance, here is at pi over 2. The other high point on the same red line is at 5 pi over 2, right? If I can find the distance between two high points on the graph, then I will have found the period of the graph. The same thing works for two low points. If I can find the period, the distance between two low points of the graph, then I'd have found the period of the graph. No, really what you're asking for is how long does it take to complete a cycle, right? How long does it take before you start repeating yourself? And this graph clearly repeats itself over and over and over. So how long does it take from the beginning of one cycle to the end of that cycle? Because when you've completed a cycle, then that distance that you traveled is referred to as the period. So in this case, the period, as I just saw from Noah, and as you heard from Jeremy a few minutes ago, the period is actually 2 pi. And in the typical sine function, the period is in fact 2 pi. Can that change? Absolutely can change, right? You can write equations that give you a very different period. You can write equations that give you a very different amplitude. We're going to be doing all of that hopefully today. But those are two concepts I really needed to nail down today, right? So what about the cosine function? If I had to ask you for the period of that one, let me erase this here. If I had to ask you for that same concept to be applied to the cosine function, what would you say? You're still saying 2 pi. Well done. Well done. So it's the same period and the same amplitude for both of these functions. They both have the same period and amplitude, right? So the amplitude is 1, the period is 2 pi. Okay. Drawing that center line helps, especially when you're trying to figure out what the amplitude is, because as you heard Jeremy say, going from that center line up to the high or from the center line down to the low, because it works both ways, is the amplitude of the function. Or, as I said, high minus low divided by 2. That works as well. Okay, so there's your sine and cosine function introduction. To some of you who may not have seen the graphs before, that's what they look like. They look at these they have these wavy patterns. They go up, they go down, they go up, they go down. They do that in an indefinite, consistent, what's called periodic way. Okay, all right. Now, by the way, has anybody joined the class late that I was not aware of? I need to make sure that I include you in my attendance. I don't want to have to call the names out again, but if you know that when I did the attendance you were not here, please make yourself known so I can adjust the attendance. Okay, I'm going to move on. Don't see anybody saying that they were absent. All right, so let's move on to the tangent graph. So again, if we were to look at the table of values, which you should be able to do because we have looked at special angles already, so the tangent of 0 is of course 0. The tangent of pi over 4 is 1. The tangent of pi over 2 was undefined, so I'll use that symbol to represent that. The tangent of 3 pi over 4 was minus 1. The tangent of pi was 0. And the tangent of 5, where am I at? 5 pi over 4 is 1. And the tangent of 3 pi over 2 is also undefined. So if you look at my graph, you'll notice that I've put in some vertical asymptotes. Why? Because this graph does have a vertical asymptote. There is a value. There are certain restrictions, which we're going to talk about in a minute. There are certain restrictions on tangent where the tangent is undefined at certain angles, right? But that's the general shape of the function. So you see it sort of going up and tending towards infinity. Then it splits and goes on the other side of the asymptote and does the same thing again. It has that kind of arching shape to it, which makes it go up towards infinity, down towards minus infinity. And so it goes on and on and on. My question for you now is, what would be the period of this function? Can anybody help me with the period of this function? Now, I'm not asking about amplitude, and I'll tell you why I'm not asking about amplitude in a minute. But what is the period of the tangent function? Right? We taught the period of the cosine and sine functions, and we nailed those. But what about the period of this one? Look at them and ask, how long does it take to complete a cycle? You can't look at highs anymore. You can't say from the high to the high because this actually has no high. It goes up indefinitely, right? And it doesn't have any lows, it goes down indefinitely. So you can't use that, but you can use the other definition of how long is it taking to complete a full cycle? Where the asymptotes lie, okay. Well, then the question is, Noah, how far apart are these asymptotes? Because the distance between the asymptotes should be the period, right? So, Karis, I'm agreeing with you and Noah on that. But how far apart are these asymptotes? Because that's going to be the answer to the question of what's the period of the tangent function. Does anybody have an answer for that? Look at those asymptotes. Does anybody think that, okay, I think some people are saying they said it. You're talking about, well, I see different answers. I see the 2 pi and I see pi, and I see it would be pi. Well done. Right? If you take any of these asymptotes and subtract them, so pi over 2 minus 3 pi over 2, right? So take this asymptote, subtract that one, or take this asymptote and subtract this one. Any two asymptotes that you subtract give you a period of pi. So it does take pi radians for you to be able to repeat one cycle, okay? Now, restrictions. What are the restrictions? Give me a few of those restrictions. Just give me any restriction that you see. So I can't talk. Let me just go back and say something else. I can't talk about the amplitude of this. This has no amplitude. The amplitude is undefined because amplitude would be how far am I from the top of the function, the highest point, down to the center. Well, it goes on to infinity. So it cannot have that. X cannot be equal to 7 pi over 2. Jeremiah is thinking. You went all the way to 7 pi over 2, right? Okay, so here's how we could write it, right? We could just write x is not equal to pi over 2 would be 1. All right, another one would be 3 pi over 2. Now you could say etc., but there's a sort of more elegant way to write it, and I'll show you what that is. You could say that x is not equal to k times pi over 2, where k is an element of the, sorry, I'm not saying it right at all. No, let me fix that. Let me fix that. 1 second. Pi over 2 plus k pi. I'm going to fix this. Hang on 1 second. So pi, oh, sorry. So pi over 2 plus k times pi, where k is an element of the integer set. Now, you don't have to use k, you can use any other letter you like. Here's what this is saying. This can give you any value of the, not equal to, by the way. This can give you any value of the restriction because all you would need to do is keep changing the value of k, but it must be an integer. Integers are whole numbers. So 0, 1, 2, 3, 4, 5, 6, 7, that minus 1, and integers can also be negative, so minus 1, minus 2, minus 3, minus 4. So for instance, if I wanted to get another value of the restriction, I would just simply add a 1k or a 2k to that, and that would give me another restriction on the on the tangent function. Okay? All right, so that's just one way that you can generate any value. So this is an alternative to simply stating 1 or 2 because you can never give all of them, but this way would give all of them, right? If you generalize it by doing this. Okay, let's move on. Let's now use the general form of a trigonometric function, which is, and I'm using sine here, but it could also be cosine. A sine k x minus d plus c. Now, you and I, or we all, did transformations some time ago, back in unit, I forget, probably unit 2. So what we're going to do now is we're going to apply some of that transformation logic to what we're doing here. I want you to look at this function and tell me, and so the A here, just so you know, right? In fact, let me bring this down here. And since some people haven't done this before, the A is going to represent the amplitude of the function. So if you can figure out the amplitude of the function, that'll be your A. The D is going to be, now what we used to call the D back when we were doing transformations before, we used to call that the horizontal translation, and I usually abbreviated that HT, but we're going to call it in this context a phase shift. So when you're doing trigonometric functions, you talk about a phase shift. So you can phase shift it to the right, phase shift it to the left by a certain number of radians or degrees or whatever. So we're going to call it a phase shift. And then the C, of course, is going to give you your vertical translation. Again, that's familiar to you. You've seen vertical translations before when we were doing transformations. And this is going to be based on the center line of the function, right? So if you can identify where the center line of the function is, then that's going to be your C. I'm going to put that as a thing to help you to build these equations when you're putting them together. The C will always be the center line. So if your vertical translation is 6 up, then it means, remember, vertical means up or down, then it means that your C is going to be 6, okay? And then the K. Now, we know from the stuff that we did before that this K has to do with our horizontal compression or stretch. So it's horizontal compression or horizontal stretch. This K is going to determine the period. I say determine because it's not going to be the same thing as the period. It's going to determine the period of the function, which we've talked about. And we're going to see if we can figure out how that determination takes place. All right? But I want you to start off with that. Now let's see if we can start to put together an equation for this function. Okay? Everybody look carefully. I can make this a little bigger for you. So let's see. Let's go to view and zoom to already at 150%, but we can go to maybe 200%. Okay. So maybe you can see that a little bit better now. And I want you to start to give me some of the pieces of the puzzle here. What is the A in this case? So Joel is saying the A is 4. Do we agree with that? Does that make sense to everybody? Sharissa says yes. Emily and Keontae also say yes, and Noah also says yes. And that would be right. So let me write that on top here. The A is equal to 4. I usually like to write the A followed by the C. So I'm going to go to the C next. I already told you that the C is wherever the center line is of the function. Sorry. Where is the center line of this function? What is the Y value that gives you that center line? Because that's going to be your C, right? No C is what Noah is saying. What do other people think? Jeremiah says 0. So C is in fact equal to 0. Okay, whatever Y value gives you the center line, in this case, the Y equals 0 line, that's your center line, and that's what you're going to use as your C. The C is in fact 0. Okay. Now, the horizontal translation is something I need to talk about some more, but I want to get to the K next, right? I need to ask you, just looking at this function, read it very carefully, what is the period of this function? Why is it equal to 4, Jeremiah says? Why is A equal to 4? Okay. So remember what you told me earlier. Okay. So you're okay then. All right. Let's get to the K value now. Confuse amplitude with period. Okay, that's fine. Let's get to the K value now. Now, we need to be able to figure out the K, but for us to get that, we need to know the period of this function. Can somebody tell me what the period is? Okay, so Noah is saying pi, Jeremiah says pi, Noah says pi over 2, but change it to pi. Okay, all right. What do other people think? I'm not going to agree or disagree yet. I want to get some other opinions on this, right? I'm getting pi from a whole bunch of you, and that is in fact correct. So the period is equal to pi. Okay, here's what I'm going to do. I'm going to stop for a bit here because I'd like you to see if you can figure out, and some of you have done this before, so this is not going to be new to you. See if you can figure out, or maybe I should just tell you. I'll just tell you what it is, rather than me trying to go to Desmos and spend a lot of time on that. I'm just going to tell you. To get the k value, you're going to take 2 pi and divide it by the period. So the period in this case is pi, so my k is equal to 2. Okay? Period is the highest point minus. No, that's not the period, Caleb. Whoa, 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 whoa. Let's back up. Let's back up a little bit here. Don't confuse the period and the amplitude, right? The amplitude is the high minus the low divided by 2. All right, that's where the high and the low come in for the for amplitude. Okay, okay, Kayla, make sense? Just want to make sure you're following that. Where did you get the 2 pi from? Okay, that's always the case, Harish. That if I have the period, I divide it into 2 pi to get what the k value is. Okay? So the period is pi. The people who said that the period was pi in the first place is right. That's why I put period equals pi. Right? The period is one full cycle. Yes, Keontae. It's one full cycle. So a full cycle has to be measured horizontally. You measure it horizontally. So where does the cycle start? Where does the cycle end? How did I get the 2 pi? Sorry, in fact, in this case, it was pi. Okay, so one way to do it, let's do it this way then. You could take 2 highs and subtract them from each other, because I did say that to you before, Kayla. So let's take this high here, which is at pi over 4, the other one here, which is 5 pi over 4, and take the higher one first, so 5 pi over 4 minus pi over 4. I think you'd agree with me that that would be 4 pi over 4, which of course is equal to pi. Can we agree on that? I would say it's easy to start with the origin. Well, just remember that not all the graphs are actually starting at the origin. So you can't always use that. We're going to get to some graphs where that is not the case. The graph doesn't even go through the origin. So you have to be careful about making generalizations about that. Not for sine. Actually, there are sine functions that will not start at the origin either. Right? And that's why I don't want to generalize that way. All right? If you have a phase shift, if you have a vertical translation, if all of those things are applied, then the graph could start from anywhere. Okay, so we'll get to some of those examples shortly. Okay, Kayla seems to be okay now. A bit confused about why c is equal to 0. Okay, so ask yourself, here's a good way to get the 0, Harish. Here's a good rule to use to get the 0. Take your high and your low, add them together, and divide by 2. Write that down somewhere. In fact, I'll put a little note. I'll make a little note here as well. So for the c value, so you take the high plus low and divide by 2. To get the a value, it's the other way. You get the high minus the low and divide by 2. So make a note of that somewhere. Okay? Make a note of that somewhere, Harish. High plus low divided by 2 gives you your c. High minus low divided by 2 gives you your a. Okay, Harish, make a little note of that somewhere. In this case, the high is 4, the low is minus 4. 4 plus minus 4 is 0. 0 divided by anything is still 0. So that's an easy one to go with. On the other hand, this works for the amplitude as well. 4 minus negative 4 is 8. 8 divided by 2 is 4. So that's why that value of a would in fact be 4. Okay? All right, so we've got, and let me go back to the k value again, because we need to write this equation for this function. To get the k value, it always is 2 pi divided by the period. Always, always, always. right? I don't want to switch over to a Desmos graph right now because that means it couldn't be in recording. Just make a note of that for now. On another occasion, I will do that with Desmos graphs to show you exactly how that works. Okay, so in this case, my k is 2. Why? Because my period is pi, and everybody hopefully is okay with the period being pi. I showed you one way to get it, which is to subtract 2 highs or 2 lows, because that works as well, from each other, and that would be the period. And then once you have the period, divide it into 2 pi to get the k value. So we have a whole bunch of stuff that we know for this equation. Remember, this equation needs to have these things. It needs an a, it needs a k, it needs a d, it needs a c. We have the amplitude, we have the c, we have the k now. The only thing we don't have is a phase shift. So I will say this, right? That's the thing that I think most people have the biggest trouble with, getting the phase shift. If you draw in your center line, it makes getting that phase shift a little bit easier. I'm going to put my center line in right now. We've agreed center line is the C, which in this case is the x-axis. I'm going to put that line in right now as a red dotted line. Okay? Here's my center line right here on the x-axis. If it's a sine function, this is kind of what maybe Noah was suggesting. If it's a sine function, then look to see where the center line intersects with that sine function on its way up. It has to be on its way up, right? So here's where the center line intersects with the x-axis, right? Oh, sorry. Let me take that away. Let me go back to my pen. Okay, so here's where it intersects with the function. The function intersects with the center line right on the xy origin, right? If that is the case, there is no phase shift. If that center line had intersected somewhere else with the function, on a sine function, and again on its way up, then it would mean that the phase shift would be something else. And I'll try to draw some examples of that a little later on, or maybe tomorrow. So in this case, there is no phase shift. So the PS, the phase shift, or what we call, what is referred to as D in this case, is 0. I'll go back to red since I was using red before. So the D is equal to 0. So I'm now ready to write my equation for this particular function. That equation would be f of x equals 4, that was my a value, sine 2, that's my k value, x, there's not minus anything in this case, so I'll just close it off, plus nothing. So in fact, I don't even need that plus anything. Let me erase that. That's the whole function right there. So it's 4 sine 2x that would generate that line that I'm looking at right now. Right? 4 because that's the amplitude, 2 because, and remember, 2 is not the period. I want to stress that. You get the period first, and then what you do is you take 2 pi and divide it by that period to get what the k value is. Okay? So there's my equation that would generate this graph. Okay, so we've just come up with our first equation based on an analysis of the various factors of the equation. Okay, we're going to try this again, folks. We need to get this whole thing straight in our minds. So we're going to try this again. I may take you over to the University of Waterloo website to try a few of their examples. I saw that it has some really nice content over there. But let's just try another one first, another one that I had lined up here. Okay, so I'll make this one, I don't know if I can make this much bigger because it's already pretty big. I think I'm already at like 200%. Let's see. Yeah, I can't, no. All right, but maybe I can go to 300%, although that's going to really kind of make things look. All right, so maybe I should. All right. So I want you to look at that. And by the way, it says here equation it says without a phase shift. I'm going to write this with and without. So I'm going to do both. I'm going to do both. Okay? All right, so first things first. First things first. Remember that we're looking for 4 things. In fact, let me copy this thing here over onto the other page. All right, so we know all the things that we're looking for. So we need all of these features to be able to write this function. So let's start off with the a. Oh, let me scroll down so you can see it some more. Let's start off with the a of the function. Right? Can anybody tell me what the amplitude, remember a is the amplitude. Can anybody tell me what the amplitude is of this function? Okay, I'm getting some 3s here. And looks like a bunch of 3s. So I'm going to say, yeah, that's good. Now, my cursor is going to be really big because I've zoomed in so much. But that's just the nature of things. So a is equal to 3. So we have the a. I always say get the c next, right? I think the a should be followed by the c. So let's get to the c now. What would you say is the c? Let me go back down so you can see it. What would you say is the c of this function? Where should that center line be? Oh, look at you. Look at you, all of you. You're such fantastic students. Yes, it's the same one that we had before, right? I think this is probably still red. No, it's back to black. So my center line is actually right here. Oh, that's not what I want. What are you doing to me? Don't tell me you're going to give me a heart. Oh, there we go. Okay, but I need to change the color. Give me a second here, folks. Sometimes things don't go exactly as you had planned it. Okay, let's stop that. And let me come back up here, touch the line, touch this, get the red, and let's try this again. Okay, there's my center line, right? Because you're telling me that my C is equal to 0. Is everybody clear on what that 0? A whole bunch of you said 0 and you're right. Is everybody clear on that 0, that 0 makes sense? I hope it is. All right, if it isn't, you need to stop me. Okay, good, thank you. So what else do we need? Let's go back up and see. Let's get to the k value, but forget the k value, we need the period first. Let me write period down and see if we can come up with what that period is. Then we can work out our k. All right, so let me take you back to the graph again. What about the period of this function? Can anybody come up with that answer? What's the period of this function? So I'm getting 3 pi over 4. I'm getting pi over 2. And lots of pi over 2. Anything else? Never mind, Keontae says, okay. Everybody is coming up with pi over 2. Okay, I agree with that, actually. The period is pi over 2. That's not your k, though, because your k is equal to 2 pi divided by pi over 2, which means the same thing as 2 pi times 2 over pi. Remember when we were doing this yesterday with those identities? What I'm doing is I'm multiplying by the reciprocal. How did I get pi over 2? Joel is asking. Good question, Joel. Well, one way to do it is this, right? It's hard to read what the highs are or the lows are to get that answer. Just take 2 things that are on the center line. Well, look at this point right here that I'm circling. Can you see that point? That's at 0, correct, Joel? Okay, looks for another point on that center line, which is doing exactly the same thing. I can't use this point because it's now going up. This one is coming down, this one is going up. So I can't use this as the end of the period. I have to go all the way over here. So it says that, what I'm saying is that from here to here represents 1 full period. Do you see that? Does that make sense? I'm going down from the center line at both of those 2 junctions. So that's one good convenient way for me to measure what the period is. Okay? All right. So we have our period as being pi over 2. All right, that's what we have up here. And for us to get the k that goes in the function, we take the 2 pi again, divided by pi over 2. Now, dividing by pi over 2 means multiplying by the reciprocal, which I'm doing here. The pi's will, I'll put this over 1. The pi's are going to cancel out. So it's 2 times 2, which is just 4. So my k is equal to 4. Okay, it looks like these 2 things are, I just want to separate them. The k is actually equal to 4. Okay. There are there's several ways of writing this equation, and that's going to come into the whole phase shift part of things now. I want to make sure we finish this before the break. We need to finish this equation before the break. I want to do two versions of the equation before the break. Now, this thing says I must write this without a phase shift. Without a phase shift. So I'm going to say that the phase shift is 0 again, right? The D is 0 because the question says so, right? Phase shift is that thing, the phase shift, the D, which is this thing right here, has to be 0 because the question says we don't want that to be the case. So if there's no phase shift, how can I make this function start off on the 0, the origin, and instead of going up like a regular sine function, it does this and goes down instead? Is there a way that you think, from based on what we've done so far with transformations, when I want it to behave in the fashion where rather than going up, it goes down, how do you think we could do that? Negative, where do you think that negative would go? Where do you think that would go? Should I put it on the C or the D or the K, or where do you think that should go? Where's a good place for that negative? I agree with you, by the way. In front of the A is correct. Thank you very much. So what we're going to do is we're going to make this A actually equal to -3. Now we're ready to write our function. Here comes the function. So y equals, so one version of the function is y is equal, this is the one without the phase shift. Y is equal to, remember the A was 3 sine, open bracket, 4, open another bracket, x. There is no phase shift, so I'm going to close the bracket twice, and there's no vertical translation, so that would be my equation. Now, that will work, but what if we wanted to write this with a phase shift? So we'll write that down here. There is more than one way to write an equation that makes you get the same graph. That's just a fact. That's just the way it is, right? If you ask me to write an equation for a sinusoidal function, I could write you a million equations, literally, right? Because there isn't just one equation. You could just change a few things and get the same graph, right? Okay, so with a phase shift, let's just think this thing through now. Let me tell you what will happen if we're going to change this thing and say with a phase shift. We're not going to ask the question. I'm going to just erase this thing here. We're not going to ask the question that I asked on the first one. A phase shift is, where does the function start from on the center line for a sine function on its way up? Where do I need to go along this x-axis for the intersection of the graph with the function on its way up? Not on its way down, but on its way up. Can anybody tell me, where do I go? So let me start tracing it out. I'm looking along this x-axis here, and I'm asking, how far do I need to go along this x-axis for me to find an intersection point where the graph is on its way up? Not on its way down, but on its way up. Okay, Noah and Harish are saying at pi/4, and Karis is agreeing. What do other people think? All right, I'm always asking that question. All right, there's some early, answers there, but what do other people think? I've got 3 people saying pi/4. Sharissa is agreeing with that. All right. Anybody else have another opinion? Joel, whoa, okay, I guess the consensus is pi/4, and you're all right. So I could rewrite this function, right, with everything else the same except one thing. I'm going to say y. Oh, sorry. Oh, sorry. Nobody corrected me about this. It's supposed to be minus. Nobody said anything about that. Did anybody correct me on that? Nobody did. Right? That should have been a minus. In fact, let me erase this. It looks much more obvious that should have been a minus. Right? We agreed that the A was going to be negative, and then we didn't put the negative in. So negative, not negative A, -3. Sorry. So -3 sine 4x. Right? So that's one version of the equation. Why does it have to be -3? We're already at that. Yes, no, that's my fault. That's my fault. Remember really that we said that this function wasn't going up at the start, it was going down. Let me take you back to that point again. Look at the graph before this one, right? This sine graph started off on the center line and then went straight up. This one is doing the opposite. This one starts the center line, goes down. So instead of going up like that, it goes down. How can we do that? We can do it by reflecting across the x-axis. And the reflection across the x-axis is when we put that negative. Does that sort of sound familiar to you already? Okay. So now we're saying, what if we wanted to write this function a different way, but with a phase shift? We've agreed, hopefully you have agreed, that that phase shift is a pi over 4. So let's write that function now with a phase shift in it. So y equals 3 sine, same value of k. Now, should I put it minus pi over 4 or plus pi over 4? Is that shift to the right or to the left? Right? Remember, horizontal translations shift to the right or to the left. So which direction am I shifting to get to that pi over 4? Am I shifting to the right or am I shifting to the left? What say you on that one? Those of you who said it was pi over 4, is pi over 4 to the right? So if it's pi over 4 to the right, I'm going to say it's going to be x minus pi over 4. Don't forget that when you're shifting to the right, you put a minus. It's still plus 0, but my other question is, do I still need that negative? Do I still need that negative if I put a phase shift in this time? What do you think about that? Or do I know, I don't need the negative anymore, right? I'm saying that I've shifted the function to the right by pi over 4, and I'm making my starting point right here now, so I no longer need that negative because from here I'm going to go up, right? So I'm not going down at the start anymore. My start has moved from being at the origin to being at pi over 4. And from that start, I am going up. So it's okay for me to drop the negative and write the function like this. So this function will do the same thing as this. On a graph, you couldn't tell that these were two different functions. If I brought up a decimal screen right now and started graphing, both of these functions would look identical. They're not the same when you write them down, but they behave in the same way. Okay? So there you go. We wrote it with a phase shift, sorry, without a phase shift. We wrote it with a phase shift. So the second version is with the phase shift. The first version is without a phase shift by just simply using a negative. Let's see if we can squeeze one more in, and then we'll take our break. Okay, look at that graph. I'll give you 30 seconds to sort of take it all in. And then we're going to see if we can write another sine function for this. We haven't started talking about writing cosine functions yet, but we'll get to that. Right? They're very similar, and we can actually take one and transform it to another. But let's just stick with sine graphs for now. I want you to look at that equation, sorry, that graph. And again, let me copy the thing on this page for you. This thing here. We need the A, we need the K, we need the D, we need the C, all of those things. All of those things. Start off with the A, right? That's a good place to start. What would be a good A on this graph? Work with me, folks. Come on, we're almost at the break here. All right, so Sharisa, Emily, and Joel think it's 2. Really? I'm gonna go with 2. Does anybody have a different answer? Nobody want to give me a different answer. You really want to go with 2 on this, right? You honestly think that 2 is the right answer. But in the equation, it should be -2. We'll talk about all of that later. All right, Jeremy and Riddy are saying yes. They're saying yes to the 2. So my tone is not suggesting to you that maybe you should change your answer. You're not buying it. You're thinking Mr. Kamak is trying to pull something fast on us, and we're not buying it. We're going to stick with that 2. Is that what you're saying? All right? Nobody wants to give me a different amplitude. All right? You're so confident about your answer that you're going to stick with that 2. Is that it? Yes, it is 2. Okay, Caris. All right, you got me. All right, I can't fool you guys at all. It is 2. All right, so let's put that in. All right, let's get to the C. How about the C, folks? Give me a C. Yeah. So look at that. We're still at 0. We haven't changed from 0. That's going to change eventually, folks. Don't be confident about putting 0 in for the C every single time. That's not the case. Okay. Period. That's the next thing we need to talk about. Remember, period is not the same thing as the K. We'll get to the K afterwards. We need to find the period. Does anybody know what the period is of this? So I see a 2 pi over 3. I see a pi over 2. I see a 2 pi over 3. So we don't all have the same answer. Keontae is now changing from what she put before to what she's now putting. And Ava is wanting to agree with that. All right. Since we're rushing to get this done before the break, I'll just go ahead and agree with you. The period is in fact 2 pi over 3. So let's get the K value now. So we're going to take 2 pi and divide it by 2 pi over 3, which means the same thing as 2 pi times 3 over 2 pi. The 2 pi's cancel out, so my K is actually equal to 3. So we got that part. All right, so we have the A, we have the C, we have the K. Let's now get to the D. Let me remind you that I will need to put the center line in to help me out with that. So I'm going to go ahead and put that center line in very quickly. I know we're running up against the clock here. All right, center line should be somewhere around. All right, that's a little bit off. Let me try that again. That's a little better. That's a lot better, actually. What would you recommend for me to put as my D in this case? Let me see how sharp you guys really are. All right, remember, look for where the graph is cutting through the x-axis on the center line on its way up. That's important, on its way up. Okay, I'm seeing some pi over 2's there. Is that what everybody else thinks, pi over 2? Or is it just Noah and Harish? It is pi over 2, correct. And it's pi, and I should say, and I'm giving a phase shift, it's pi over 2 to the right. That's important. Let me quickly write the equation in because you've given me almost everything. So y equals 2 sine 3 x minus pi over 2, and that's it. I'm going to move on now to my next graph. All right, hopefully everybody's clear on this graph, by the way, before I go any further. Right, I mean, in fact, we rushed a bit towards the end of that one. So let me just quickly go over the one that we're on right now. This graph has an A, which is the amplitude of 2, right? Because you go from a high of 2 to a low of -2. So if you subtract those two from each other, you get 4. 4 divided by 2 is 2. The C is 0 because the center of the function is still at 0. We haven't changed that yet. The period of the function was 2 pi over 3. One way to get that is to look at the high point here and the high point here, see how far apart they are. And it was a 2 pi over 3 distance there. So that's one way to get it. You could have used a distance from maybe this point here where it's going down through the x-axis to this other point here, subtracted those two, that would have worked as well. The K comes from taking 2 pi divided by whatever the period is, and it works out to be 3 in this case. Okay, then we need a phase shift. And for the phase shift, we said, how far along the x-axis do we have to go for the graph to be cutting through that center line on its way up? That's how we do it for a sine function. You should refresh your page. Keontae is saying, what's wrong? You don't see, you're lagging right now? Is it Isaac's issue or my issue? I need to be sure. Can everybody hear me? Okay, so everybody else is okay so far? Yeah, these things happen, you know, in the middle of sometimes the most intricate things fall apart. I understand that. Okay, you can hear. Perfect. All right. So I'm just reviewing this one very quickly. There is a way that we could have, in fact, let's just challenge ourselves, right? Let's challenge ourselves. What if I wanted to write this same function, but with a -2? Can anybody tell me how else this would have changed if I wanted to write this with a -2? And I see some hands going up. Let's see who was first. Noah, and then Jeremy. Noah, please go ahead. I'm listening. Well done. Well done. The only thing that changes apart from you putting a negative there, so I'm going to put sign here. The 3 is still there because the period hasn't changed. But now we're going to make a phase shift of x minus, in this case, pi over 6. Because that's where we had to shift to. Jeremy, did you have a different answer? I should have asked you for your answer before I said anything, actually. I'm sorry about that. You have a you'd have said the same thing. Okay. So that's what the difference would have been. Again, it's just another equation that gives you the same graph. And what I'm trying to stress to you is that there isn't one right answer for a trigonometric graph, right? As long as sometimes when I'm marking these things, I have to have my Desmos standing by because you might give me an equation and the best way for me to see if that equation works is just put it in Desmos and see if it works for the equation I'm actually looking for the graph that I'm actually looking for. So there you go. This actually would give you both of these on Desmos. They look exactly the same. Can't tell the difference. Okay? All right, things just changed. And then I also have something on here. I'm going to have to zoom out now, folks. This is ridiculous. It's getting ridiculously big. So let's zoom to maybe 150%. All right, I'm sure you can see that still. And I have something at the top of the page here, which we have to pay attention to because we're going to get to a point where we're writing sine and cosine equations. And I have a little note there that says that if I start off with a cosine equation, add a period over 4 to it, it gives me the sine equation. And that if I start off with a sine equation and I minus a period over 4, it gives me the cosine equation. I'll interpret all of that for you in a little while. But let's get to writing a sine equation for this first. So things just got interesting. 2 things that you'll notice. Well, let's see what's the difference. What's one of the big differences here that you notice with this picture that you're looking at right now compared to the ones that we had before? Give me some differences. The c is not 0. That's true. That's absolutely true. The center line is not 0 anymore. Does anybody notice anything else that's different? Yes, I agree with you. But anything else that's different between Harrison and Jeremy, well done. I can give you full props to that. What else is different about this? Is there nothing else that's different about this graph compared to the ones that we had before? Uses whole numbers on the x-axis. That's a very good observation. So this axis is not in terms of pi, like the ones that we had before, where we had, it was pi over 2 and pi over 3 and all that good stuff. This is not. So we can write an equation for a sinusoidal function, which gives us regular ordinary numbers, which are not multiples of pi. Thank you, Harish. So thank you, Jeremy. Thank you, Chris, for all of those observations. Those are very valid observations. So let's go through all the things that we talked about before. Let me put that thing again down here. I still hope it's still on the, yeah, I think it's still there. Here it is. We still need all of these things to be able to draw this graph. We need the A, we need the K, we need the D, we need the C. But now it's a little bit more challenging, but we can do this, right? We can do this. Let me start off with the A, right? Let me start. Where do I write this stuff now? All right, let me move this. Oh no, that can't work. I'll do it down here. All right, I want you to be able to see the graph while we're putting everything together. So let me move this up a bit. No, that doesn't work. Yeah, actually, I can move that up as well. Okay, so let's start off, and I can move this maybe over here on the side. Sure, you can still see it. Or maybe up here. Yeah. Okay. So let's start off with the A. I'll use black this time. What's the A equal to for this function? Getting some 4s for some reason. Some people think it's 4. Come on, I want to see some more answers. Maybe different answers. Maybe that's not the number I'm looking for. Maybe. Is there another answer? Jeremy's going to double down on this 4. Nobody and oh jeez, okay. I just can't fool you guys. Yeah, I just there's nothing I can do to shake you when you have your answer. You're pretty convinced of yourselves, eh? Okay, all right. So it's 4. All right. So by the way, sometimes when I push you, could be because you're wrong. Let me just make sure you know that. Okay. Stone cold. Okay. All right. So A is 4. A is 4. I agree with you. We always say, oh wait, I always say, I shouldn't say everybody says this, but I always say that you should go next to your C. So let me hear from you on the C now. What do you think the C is in this case? Right? Where is that center line in this case? Getting a bunch of -3s. Okay, Keontae said 2 though, so maybe Keontae is right. But a lot of people think it's -3. Nobody wants to go with a different answer from -3. All right, let me remind you what I said is a good way to get that center line. Okay, yes, I can see. I can see you're all going to go to -3. A good way to get the center line is to add the high and the low. So the high in this case is 1. The low is -7, so plus -7. And then you're going to divide that by 2. 1 plus -7 is -6. -6 divided by 2 is -3. So yes, the C value is in fact -3. No argument here. No argument here. Next question is, what is the period of this function? Now, it's not the k. We'll get to the k eventually. But what is the period of the function? Can anybody answer that question? The period of this function. Okay, I'm getting some 4s for that. All right, I'm getting 4 from 3 of you. 4 of you think it's 4 now. What else do people think? Keontae. I hope it's not just people just looking at what other people put and then they put the same answer. I hope not. I really hope not. Because you could be writing down the same wrong answer. But no, the answer is in fact 4. That's the period. You're right. So my k now, I'm going to do the same thing. It's 2 pi divided by the period. So in this case, it's pi over 2. That's my k. Just reduce down the fraction to the lowest terms, pi over 2. So we have the a, we have the c, we have the period, which gives us the k, sorry, right? It's 4, yeah, right, yeah, that's good. Okay, I see a question here. Why is it, okay, what is it the last thing I wrote, Aliza, that doesn't make sense? The pi over 2, what are you questioning here? Because I don't mind going over something if you're not sure. Aliza, is there something you wanted me to go over? Why is the period 4? Okay, that's a perfectly legitimate question. So let's answer that question. All right, but that question is coming from Joel. Aliza, are you okay? Because you put something here that I can't quite decipher. So I can't answer that if I don't understand the question. All right, Joel, let's answer your question in the meantime until I hear from Aliza again. A good way to get the period, like I said a few minutes ago, is take 2 high points and find the distance between them. Right? Look at those high points there, Joel. You see the high points of this function? The x values of those high points? Right? So one high point occurred at -1, correct? Yeah? And where's the next high point after that? Where's the next high point? Which x value gives you the next high point? No, no, that's not at 4. The next high point is not at 4 at all. Not at 2 either. Which x value, look at the graph carefully, which x value gives you the high points? Look along the x-axis, look at the graph to see where it peaks, and see what x value gives us those high points. All right? So the next high point is at 3. Okay. In fact, look at the next high point after that. What's the next high point after that? Where does that occur? After the 3. Okay. How far apart is 7 and 3? That's your answer. That's why the period is 4. Okay. If you wanted to go from -1 to 3, that's also a distance of 4. It's just how far apart are the highs or the lows, same thing. I could look at the lows as well and get the same answer. Okay. All right. Thank you for that question, Aliza. I still don't have an answer for you because I don't understand what you wrote down. Is there something that you wanted to ask, Aliza, that I can answer for you? No? Okay. I'm going to move on then. I am going to move on. All right. So we have our A, we have our C, we have our K. What we don't have is the D. Now, the D is going to depend on whether we want to make the A negative or not. Let's say that we don't want to have a negative A. Let's just put it that way, right? Let's say that we're going to start writing this without, how do you find the D? Okay, well, is this cosine or sine? Good question. We're going to stick with sine for now because that's the one that we have been practicing. And later on, we're going to see how we can shift and make it into a cosine. We're going to talk about that a little later on. How do you find the D? Okay, so let me put that center line in for you because it's important to have the center line in, I think, for you to figure out what the D is. I'm going to go ahead, put in my center line. We said the center line was at -3, remember? That's terrible. Hold on. That's much better. So there is my center line, Rachel. So I want you to think now. Let's write both. We'll write both versions of the function, actually. Let's write the version without the negative first, Rachel. So we're going to say that y equals, we come back over here. So far we have the a of 4. It's been signed so far all the way. Sine of the k was pi over 2, x something, and then we're going to say -3 on the end. So we have x plus or minus some number. That's where the phase shift comes in, Rachel. And not just Rachel, everybody else. I'm going to look at the graph and ask, okay, there's my center line at the -3. You see that center line there, Rachel? Can you see where the center line is on the graph? Can you see that? Okay, so we're going to ask the question now. Where does the function or the graph intersect with that center line on its way up? Because that will be my phase shift on its way up. How would you answer that question? How far did I have to go? Is there always a graph where the A is negative? Is there always a graph where the A is negative? You can always write it with a negative. Yeah, you can. As long as you make your phase shift match so that it will work. Yes, you can always write it with a negative if you want to. So you're saying at -2. I agree with you. I absolutely agree with you. So it means that since you can go to the left 2, I could say that the phase shift is 2 to the left, in which case I could write x plus 2 as my phase shift. Excuse me. No, go ahead, please. Absolutely, because we went to the, and as I was hoping somebody would say that, would notice that. I could have gone to the right by 2 and gotten the same result, right? Because whether I go to the left 2 or to the right 2, I'm still going to be cutting through the center line on my way up, and that works both ways. So I'll accept the answer that we got from Rachel, and because it's a -2, because it's to the left 2, I'm putting in +2. But it would be just as good to have written a -2 there. Okay, so our challenge was, and this is something that I hope will address Jeremy's question. Can we write this with a negative? What if I wrote -4 sine? The other stuff is the same, pi over 2, except the phase shift. What do we write as our phase shift this time? So remember now, if it's that you're going to go with a negative, you're going to ask the same question. Where does the graph cut through the center line? But, oh, Aliza is back. Aliza, you seem to have dropped out there for a while. Are you able to hear me, Aliza? Because we were asking for you to clarify the question. First of all, are you there with us, Aliza? Can you hear me? My Wi-Fi went, okay, that's fine. So you put something in the chat, which I know you can't see anymore because once you join, you lose all the stuff you had in the history. But you put something in the chat like you had a question, and I didn't answer the question because I couldn't understand what you were asking. Was it something you wanted me to clarify? Was there something you wanted me to? Oh no, sorry, I think it was a type. Okay, all right. So let me move on then. So we're now trying to write this function with a negative a. And to answer that question, we're going to go back to that center line again. And we're going to ask, where does the graph cut through the center line, but on its way down this time? Right? Because on its way down means that you've had that reflection on the x-axis. And that's why it's going down. So if it's going down as it crosses through that center line, right? What kind of phase shift do we need this time? Look at the graph carefully. What kind of phase shift should we be using? Anybody? I'm not asking anybody in particular now. Harish says no phase shift. What do other people think? I want to get some more reaction from the room here. Harish says he doesn't think there needs to be any phase shift at all. All right, so let me say it again. But the center line, I think having that center line is important. And ask, where does the graph cut through the center line on its way down? And how far do I have to go from the y-axis for that to happen? From the x-axis, yeah. So in other words, how far along that center line do I have to go from the y-axis to get the function to be going down through that center line? Harish says I don't have to go anywhere, right? So it means that's correct. I don't need a phase shift in that case. It's just simply x. No phase shift required if I use a negative. Okay? Now, there's something else we're going to be doing here, which is to write for the first time a sine function. Sorry, a cosine, I'm sorry. A cosine function. We haven't written a cosine function yet. You can actually, for the very same equation, for the same graph, you can write either a cosine function or a sine function. I'm going to teach you two ways to do it. I'm going to teach you a way where you can actually just look at the graph and figure it out. Or if all you had was the equation and not the graph, you could actually get the same answer. So I'm going to show you both. So what I'm going to do is actually, I'm going to copy this whole page and put it on a different. So let me select all. Here we go. Copy the whole thing. And we're going to paste everything onto this page. Except for, actually, I'll tell you what except for is in a minute. Oh, click on that there. So some of the stuff that we're doing here is going to be relevant. Some of it is not. I'm going to erase this stuff here. All these three things are not changing for us to write a cosine function. We just have to change a few things. The main thing we're going to change is the phase shift. So I kept my previous page because my previous page was all about sine functions. This page is about cosine functions now. And I have something at the top of the page here, right there, and right here, that says if I have a sine function, if I take the period divided by 4 and subtract it from my sine function, it will turn into a cosine function. So we're going to try that first. Then we're going to use the eyeball method, which is to look at the graph and use the graph to come up with, hopefully, the same answer. So let me focus on this here. Let me circle it. Oh, sorry. Let me circle this. Circle it in red. We're going to, well, that's not red, but anyway. Let's see if we can make this sine function. If I subtract the period divided by 4, make it into a cosine function. We're going to try that. So let me come down here. The period of this function is 4. I think we all agreed on that. When we were doing this before, we said it was 4. So actually, you know what? I should not have erased my sine function before. Let me get my sine function so I can put it back. We actually had two versions. You know what? Let me just Tell you what, I'm just going to delete everything, put it all back. Just delete everything, put it all back. 1 second. One more time. I think we're there now. Are we there yet? There we are. Okay, so these are the sine functions that we had. I should have deleted them because we're going to use one of them to create a cosine function. Okay? Now, this thing at the top says, if I start off with a sine function and I minus a quarter of the period, it just turns into a cosine function. Okay. The period in this case, remember, was 4. So I'm going to take 4 and divide it by 4. So this is the period that we had. 1 second. This is the period that we said we had of 4. So I'm going to take 4 divided by 4, which of course is 1. And I'm going to take the function that we started off with, which is this one here. And I'm going to take the phase shift that's on there now. That phase shift is x plus 2. And according to what this thing says at the top, right, I'm going to minus that quarter of the period from the phase shift that we have on the sine function. So I'm going to minus from that x plus 2, which is the phase shift here, I'm going to minus 1 from that. Why minusing 1? Because that's a quarter of the period. What I'm going to end up with is x plus 1. This represents my new phase shift on a cosine function. So I'm going to go ahead and write my cosine function now based on having just done that. Just subtracted a quarter of the period from my sine function. So here comes my cosine function. Everything else is the same. So y equals, here's a function, for cosine, it's still pi over 2, but now it's going to be x plus 1 minus 3. So there are certain things that did not change, right? This didn't change. This didn't change. And that didn't change. Those 3 things did not change. What changed was my phase shift. And what you need to recognize is that a sine and a cosine function look almost identical. Let me take you back to the first page for a minute, just to sort of prove what I'm saying here. Remember when I was drawing these functions? These sine functions and these cosine functions look almost identical. If I just were to shift the cosine function slightly to the right, in fact, by a quarter of a period, it would overlap with the sine function. There are a quarter of a period difference between those two, right? Look at the top. Let me erase this to show you what I'm talking about, right? Look at the top of this function. This function is at pi over 2, right? This function starts off at 0. This one starts off at pi over 2. If I just added a quarter of the period in this case we said was 2 pi. A quarter of 2 pi is pi over 2. Just shift this to the right by pi over 2. This cosine function is going to behave just like a sine function, right? Or the other way around. Take a sine function, shift it to the left by a quarter of a period. It's just going to look like a cosine function. So we can always make a cosine function behave like a sine function by just doing a phase shift, or a sine function behave like a cosine function by just doing a phase shift. And that's exactly what I'm talking about. And that phase shift is a quarter of the period. So let me go back to where I am right now, which is here. And let's continue writing that cosine function. Actually, finish writing the cosine function. It's right there. If I wanted to do the same thing with this one here, right? This one that had the negative. Then remember, I'm minusing a quarter of the period. So I just write this one as being x minus 1. So the other way of writing this, I'm writing another function that's going to do exactly the same thing. So y equals minus 4 cosine again, pi over 2. But I'm going to say x minus 1 because I'm minusing a quarter of the period, minus 3. Right? That would be the same graph. Right? The one has a positive 4, this one has a negative 4. We took the negative 4 function, the one that's up here, and it was just simply x, so we minus 1 from this phase shift. Right? This had no phase shift at all. We just minus 1 from that, which is why we have this new function here, and it's going to be exactly the same. These 4 functions All right, all four of these functions, this one, this one, this one, and this one, will all look the same on a graph. Right? Desmos will not be able to tell you them differently unless you change the color. The only thing that will change is the color. But they're going to behave in the same way. Now, could we have gotten that by eyeballing it? Well, let me change things up when we're writing a cosine function. Let's agree, first of all, that things like the amplitude and the c value don't change between a cosine and a sine function. If I ask to write a cosine function, then that function will still have an amplitude, in this case of 4, and a c value of -3. That's not changing. The other thing that's not changing is a period. It's the same period. It doesn't matter whether this is a cosine function or a sine function. The period is still going to be what we said it was before, which is 4. Right? That's not changing. What does change is the phase shift. Now, for writing this as a cosine function, we ask a different question. When we're writing as a sine function, we said, put the center line in and look for where the graph intersects with the center line. But for a cosine function, we ask the question, where is the high value? It's that simple. Where is the high value? How far did the high value shift from the y-axis? Right? Well, if you look at this particular graph, our high value is at -1, which is 1 to the left of the y-axis. So that would mean that my phase shift would be, excuse me, x plus 1, which would have been what we had right here. Right? That's exactly what we wrote here, x plus 1, because I shifted to the left by 1. Where is the high value? The high value is at -1. So I shift to the left, so that's why it's plus 1. The other thing is, when we wrote it as a negative, it means that we're not looking for the high value anymore, we're looking for the low value now. The low value is down here, which is 1 to the right, and that's why I could have written it as x minus 1 with a negative, because I'm going down and looking for the low value rather than the high value. So if you don't want to write a negative a, if you want a positive a, use a high value. How far is that high value from the y-axis? If you don't mind writing a negative a, then you look for the low value and see where that low value is from the x-axis. And that's how that is done. Now, I just saw Noah write something in there. Yeah, you're right, Noah. We could have written this with a phase shift of 3 to the right as well. Would that be with a positive a or a negative a, though, Noah? Should the a be positive or negative in that case? Yes, I could have written x minus 3. I agree with you. It would be positive because using the high value. Absolutely, Noah. Absolutely. 100%. Now, remember, this works, what we just did. If I didn't have the graph to look at, for me to be able to use the graph to come up with an equation, I could just use the equation and figure out how to shift it from a sine to a cosine by using this thing I just put on here. If it's a sine, minus a quarter of the period to make it into a cosine. If I start off with a cosine, add a quarter of the period, it becomes a sine. We'll have some more practice with this on the next slide. Okay? All right. Am I going too fast here, folks? Slow me down, stop me if I'm going too fast. Right? We'll have some more practice, but stop me. I'm not giving you any homework tonight. You had quite a pretty challenging homework last night. I get that. So I'm giving you a break tonight. Right? It is good for you to practice these skills, but I'm going to give you a break tonight on the homework. All right? Let's get to the next question. Let's get to the next question. So on this one, we're going to be writing both again, sine and cosine. Now, we may be able to do it from the graph. We may be able to do it by just simply, well, we'll have a graph. Let's start off with a graph. And if I ask you for sine and cosine, whichever one you choose to write first, you can use that thing I just talked about, which is you can go from sine to cosine or cosine to sine by using that quarter of a period of the trick I just showed you. All right. So which one? Let's start off with a sine in this case. All right. So I'm going to ask some of the same questions again for a sine function. Analyze that graph in front of you for a few seconds. Can't give you a long time. And we're going to start coming up with the A, the C. We're going to come up with the phase shift, the period, all of that fun stuff that we've been talking about for this particular graph. All right. All right. So let me start off, and I think I'll give you enough chance to write that down. Let me start off now with the amplitude of this function. We go back to black. Folks, I'm ready for your answers. Come on, throw those in the chat or just unmute and talk to me. Okay, I'm getting some threes. Getting a bunch of threes there. Any more answers? Any other answers apart from what Karis, Joel, Noah, Emily, and Jeremy have put in there? Any more answers apart from 3? Or do you all think 3 is the right number? I'm not confirming or denying. Janaya and Isaac are chiming in with the 3 as well. All right, so I'm going to confirm that the A is in fact 3. Good stuff. You know, I always like to say you always get your A and your C. So let's go to the C now. Any answers for the C? Okay, I'm getting some 1s in there. In fact, I'm getting all 1s. I'm getting all 1s in there. Does that mean that it's right? Huh? You all think that that is right? Well, at this point, I know that you guys are so ahead of the game that I shouldn't question you at all. Yeah, C is 1. I actually agree. All right, remember, high plus low divided by 2. That's the way to get that 1, right? The high here is 4. The low is minus 2. So 4 plus minus 2 is 2. 2 divided by 2 is 1. There's your answer. What I'm going to do is I'm going to put that center line in right now. I think it's useful to have that as a reference point for getting things like the phase shift and sometimes helping you define what the period is and all of that. So when I'm trying to get a graph, I immediately put my center line in. So I'm going to put that center line in right now at the 1. Right about, okay, that's not good. Try this again. Right, no, that's still not good. Come on. Okay, one more time. Whatever comes up, comes up. There's my center line, approximately. Here's my center line. Could I explain how A is 3? Of course, really. Of course. Remember, one way to get that center line is to follow this formula. You ready to write this down? Ready? Write this one down for me. Take your high, subtract your low, and divide that answer by 2. So work with me on this. What's the high in this case? How high does it go on the y-axis? What's the highest point? 4. What's the lowest point? On the y-axis, minus 2. Take the 4 and subtract the minus 2. And tell us what you get when you do that. 4 minus the negative 2. Good. Divide that by 2. There you go. So it's half the distance between the high and the low. Make sense? Are we good? Okay, good. All right. And the C, of course, is doing the other way, which is you add them together and divide by 2. All right. And I appreciate those questions. So please keep them coming. I applaud the readers of the class who don't sort of just sit passively, excuse me, and ask when they're not sure. Right? So that's you should all be readers. All right, so let's keep going. How about the period? That's a bit of a challenge. What's the period of this one? Does anybody have an answer for that? Okay, I'm seeing some pies in there. It's interesting. Is there any other answer for that apart from pi? Or is pi the answer? Is that it? Does anybody see anything else? See, putting in that center line was useful. Let me ask you that question now. The people who got it, by the way, you got it right. It is pi. Putting in that center line, wasn't that very useful to getting what the period is? Because if you can find 2 points along that center line and figure out how far apart they are, that kind of helps a lot. So I use my own method. Okay, no problem. That's fine. You know how I go on this, right? You find your route that takes you consistently to the answer. You take that route. I have no issue with that whatsoever. Right? Anyway, so I'm going to agree that the period. Oh, sorry, I keep doing that. I keep doing that. The period is equal to pi. So now that I've gone through this a couple of times, what's the k value then? The period is pi. What k value should I be using if the period is pi? And that's 100% correct. That k value is 2. Excellent, excellent. Okay, so what are we writing here, folks? We'll continue, since we started off with sine, we'll continue with sine for now. Then we're going to change it to a cosine later on. So let's start off with a sine function. So for a sine function, let me state that categorically. For a sine function, and let's also, okay, let's just say something else. Let's say the a is going to be positive. Okay, so let's go to positive a on this one. For a sine function with a positive a, so we want to keep a as being positive 3. But we'll write both. We'll write both. But let's say the a is positive. What would be my phase shift? And in what direction is that phase shift? Give me both. What's the phase shift? And what direction am I going with that phase shift? Okay, that's my question for you. Give me the phase shift, give me the direction. Okay, I see one answer so far. I see 2 answers so far. And they're both the same. Doesn't mean they're both right, but I want to see what some other people think. Right? What's my phase shift? For A to be positive. Yes, we are saying A is positive. That's important for me to say that. The A is in fact positive. Right? So really is chiming in with the Karis and the Jeremiahs of the class. The rest of you seem to be a little tentative, like you're not so sure. Right? Is it that you need another explanation for that, or no, that's right? Okay, Noah's gonna say that he's good with that. What do other people think? Or is it that you're not so sure? I mean, I need to know, right? It's okay to ask if you're not so sure. Okay, pi over 3 right is what AXA is saying. I mean, okay, good. All right, so you're right. So I'm going to write that down. So this is for a sine function, by the way. So for sine, pi over 3 right. So we have enough for us to write this equation. Here comes one version of the equation. Remember, there's more than one. So y equals 3 sine, open, 2 is our k, x minus pi over 3, close, plus 1. Perfectly correct. Perfectly correct. That would work just fine. What if I wanted to write a minus? Let's go to another version of the equation. Minus 3 sine. So we know everything is going to be the same, but we may need a different phase shift. All right. Let me take you back to the graph for a second. What if I decided I want to write this with a negative sign? What would your answer now be for the phase shift? Okay, I see Noah's answer there. He says left by pi over 6. Karis is in that corner. All right, Karis is going to ride that train. But what do other people think? Right? I don't want you just to be following what one person says, because you might have a different point of view. But I guess you don't need a different point of view. It's left by pi over 6. So I'm going to write x plus. All right, that's a weird looking plus. X plus pi over 6. All right, so here's my challenge to you now. All right, I've done all the heavy lifting. A lot of you have come and chimed in and helped me out on this. I need to write a cosine equation now. Okay, so let's see, pi over 3. It is pi. Oh, where's pi over 6 coming from? Jeez, oh my goodness. Yeah, I'm just making up stuff now. Hold on, let me just see. No, it is pi over 6. Why do you say pi over 3? No, it's pi over 6. No, why am I changing it? It is pi over 6. If you look at the graph, and if it's negative, then it means that the point that is on the center line is right here, and it's going down is pi over 6. So x plus 5 is 6 is correct. I'm not changing that at all. Come on. So you're thinking it should be changed here? Can I scroll up, please? I sure can. All right, so my challenge for you now, I'm going to give you a couple of seconds to come up with an answer. My challenge for you now is to write me a cosine function. Right? That's a pretty big challenge, right? Now, whether you want to look at the graph to do this, or you want to use the thing I told you before, and I can copy and paste it onto this page if that helps you out, right? That if you have a sine function, let me copy it, that you can easily get to a cosine function. I'll drop this right above the graph, actually. I'll drop that right here. We know what the period is. We know what the current parameters are. Sorry, could you scroll down a bit so I could see the equation we found? Absolutely. All right, so it's going to be difficult for me to show you both. So what I'll do is I'll see if I can copy the equation at the top here. So let me see if I can do that. Let me see if I can do that. All right, so copy. I'll drop that up top here. There's your equation. Okay? Noah, does that help you out? Okay, you're welcome. So I have the equation, I have the graph. You do what you need to do. I'm going to sit and wait for a couple of minute or two and ask you to complete an equation. But a cosine equation, sorry, let me just be clear on that. I need a cosine equation this time. We have a sine equation already. We have two versions of it, one with a positive a, one with a negative a. I need to come up with a cosine version of the equation now. So I'll give you 2 minutes for that. It's now 12:05. Hall pass, Emily says. Okay, Emily, within 5 minutes, please. Jeremiah, please don't do that. Don't do that. Just hold on to that. I don't. We're not using that as necessarily the answer. I just want to hear from other people yet. Don't put anything in the answers yet. Okay, so without necessarily thinking that what you just saw in the chat is correct, what do people generally think is the answer? Right? I don't want to target anybody yet. I have my wheel that I can go to in a second if I need to. But what happens to the phase shift? Remember, everything else is going to be the same, right? What happens to the phase shift of the new function? What do other people think? I've seen one answer, but I'm not going to say it's either right or wrong. I want to hear from other people on this one. And if you're not sure how to do this, we can certainly go through it, but I want to hear other answers first. Anybody? Did nobody else come with an answer? You got that as well. Interesting. And Noah's saying the same thing. You got that too. Keontae got 0. So you're saying no phase shift in that case, Keontae? Is that what you're saying? I want to be clear on what you meant by 0. So you mean no phase shift. Interesting. Okay. Okay. So Emily is back. Great, Emily. Do we have a consensus on this? Let me go through the process. Let me go through the process. Right now, our phase shift, if we were to use this version, because I mean, it depends on which version. If we're using this version, so this version at the top of the page right here, then the phase shift currently is minus pi over 3. I said that you could take a quarter of the period. Now, the period is pi. So take that pi, divide it by 4. So it now becomes pi over 4. That's the quarter of the period. So take the minus, we come to the bottom of the page here. So take the x minus the pi over 3 and minus from that pi over 4. That's what we're going to do. That's exactly what we're going to do. The common denominator here is 12. So this would be minus 4 minus 3. Both of these are pi, minus 4 pi minus 3 pi. So yes, minus 7 pi over 12. So my new equation would be y equals 3 cosine 2 x minus 7 pi over 12 plus 1. That's what my cosine equation would be. Now, it's kind of difficult to look at the graph and tell that, because what I said the last time is look for the high points of the graph. Where's the high point? And see where that high point is to know where, because remember, we're looking for a cosine function this time, right? And you're looking for where the high point is. Where there are two high points. There's one high point here if you want to shift to the left. There's another high point over here if you want to shift to the right. This is the one that we just got. It's between minus pi over 2 and minus 2 pi over 3. Looks like it's about halfway between those two, as a matter of fact. If you were to take those two values and find a halfway point, you would in fact get 7 pi over 12, just so you know. So that corresponds to our answer of a shift to the right of 7 pi over 12. Okay? Let me do a quick check-in again. Is everybody with me? Is everybody following along here? Right? I need to hear from Kristen. I need to hear from Kayla. I need to hear from Omar. Kristen, Kayla, Kayla, sorry, and Omar. Where's Omar at? Omar, looking for Omar. Okay, so everybody is paying attention there. Let me try 2 more. Sharisa and Riddy. Sharisa and Riddy, where are you? Where's Sharisa? Okay, got you, Riddy. Where's Sharisa? Okay, perfect, perfect. Like it when people respond when I call out. I always make notes of those who are not responding. So glad to hear that you're still there. Okay, let's get to the next page and see what's there. This is a cosine equation, right? I'm going to ask you now, we're going to do this together. We're going to do this one together. I'm going to see if I can take this cosine equation and make it into a sine equation. So we don't have a graph this time. No graph anywhere, right? But what we said, and I'll go back to the previous page and I'll copy this thing down for you. What we said is that if we take a cosine equation, let me copy that and put that on the same page. Copy. Whoa, what's going on? Oh, geez. All right, let me undo that. And let's come back over here. Let's see if I can paste that. That's not what I wanted to paste. That's not what I wanted to do. Undo that. I'll just write it down. Cosine plus the period over 4 equals sine. All right, that's basically the premise of this. Okay, Elizabeth, within 5 minutes, please. It's 12:13. No, I don't know what the period is. Why do I write pi? It's not pi. Period over 4. Sorry. Let me change that. Let me change that. Let me change that. It's not pi. It's period. The period divided by 4 gives me the sign. Okay. So the question is, what is the period? I mean, we know how to take the period and find the k, but now we have the k. The k is pi over 3. Well, let's just write this down. Remember what we said before? We said that the k value was equal to the period. Sorry, 2 pi. Why am I writing all this nonsense down? Sorry, folks. Okay, let's get it right, Mr. Kamak. 2 pi divided by the period. Right? We said that from before. So if we had the period, we took the 2 pi divided by the period, we get the k. Turns out, if you look at this thing algebraically, we could exchange a period and the k. So in other words, you could say that the period is equal to 2 pi divided by the k. So it actually works both ways. So if I start off with the k, and what I want is the period, I could take the 2 pi divided by the k and get the period. Okay. So what about this case? In this case, I have the k as being pi over 3. Right? So for me to get the period, I'm going to say that the period is equal to 2 pi divided by pi over 3. Or 2 pi times 3 over pi. Put that over 1 if you like. The pi's are going to cancel out. And I'm left with 6. That's the period. Right? So now what I'm going to do is, because I want to be able to use this equation to come up with a sine equation, I'm going to divide that by 4. So I'm going to say 6 divided by 4, which in decimal terms is 1.5. And I'm going to add that onto my current phase shift. My current phase shift is x minus 0.5. I'm going to add on 1.5. I'm not subtracting this, I'm adding on. Right? So x minus 0.5, that's the current phase shift. There's my phase shift, x minus 0.5 right there. Right? I'm going to add on a quarter of the period. So 6 divided by 4 is 1.5. And that, of course, is x plus 1. Do that math for yourself. Minus 0.5 plus 1.5 is 1. So my equation would be all of the other things that I had before. But now I'm going to say y equals 2 sine pi over 3, sorry. X, oh geez, I don't know if I have enough room here. Let me make this smaller. 1 second. Let me do a better job of that. Okay, so y equals 2 sine pi over 3. That's not changing. But now I'm going to say x plus 1 minus 2. So the only thing that changed, thank you, Elizabeth. The only thing that changed was the phase shift. All right, the phase shift used to be x minus 0.5. The phase shift is now x plus 1. How did I do that? Because I took the period, which I had to calculate, right, by taking 2 pi divided by k, which turned out to be 6. And I took a quarter of that, which is 1.5, and I added it on. So now I have x plus 1. And I just simply wrote the whole function again, but now it's a sine function. And now the phase shift is x plus 1 rather than x minus 0.5. That wasn't too hard, was it? Well, let's find out how well that stuck. I want you to write me a sine function, everybody. I want you to take on the challenge of writing me a sine function that would look the same as that one. Give me a sine version of that. Do I need to go over what I did before with you, or is everybody clear on that? I mean, let me know, because I don't mind going back and going over it again. Or is everybody clear on it? Can go back? No problem, Jared. Let's go back again. We'll go over all the steps again. So this was my starting point. It's a cosine equation. Okay? And I said to go from cosine to sine, I add. So before, when I was doing sine to cosine, I was subtracting. Now we're adding a quarter of the period. So to get the period, we need to take the 2 pi and divide it by well, first of all, it's just when we started off, we were saying that k is equal to 2 pi divided by the period. But it turns out that to get a period, we can take 2 pi divided by k. So that works as well. All pass and my Wi-Fi keeps cutting out. Okay, Janai, hopefully that will be sorted out soon. So all I was doing was showing you that, yeah, this works to get the k, but this works to get the period as well. If I started off with the k, which we have here, the k is pi over 3, then all I have to do is take 2 pi and divide it by that k, and I'll get the period. Because I need the period, Jeremy, for me to be able to divide it by 4. All right? The equation doesn't give me the period directly. It gives me a k value. So I need a period. So I took that k value, took 2 pi and divided it by that, which gave me 6. I took that 6 and divided it by 4. Then I took that and added it onto the current phase shift. It was x minus 0.5. That's my phase shift right here, x minus 0.5. So x minus 0.5 plus 1.5 is x plus 1. All right? So that's the process. Let me move forward now. And thank you, Jeremy. I like when people do what Jeremy just did, right? And I think it was Riddy who was doing that before as well. Stop me. What's the process? I didn't get that. Let's do that again, right? And I'm okay with that. All right, so let's go to the next page now. Oh, that's not the next page. This is the next page. And ask you to do the same thing, right? Give me an equation that would do the same thing as the one that's there right now, right? That's your task. Go ahead, please. All right, Noah, let's start with you. How do I change my sine function phase shift? What did you come up with? Go ahead. You can either speak or just put it in the chat, either one.